Hello all. Today we discuss about in this lecture 8051 microcontroller. So first of all, before starting the concept of microcontroller, first our topic is what is the difference between microprocessor and microcontroller. Okay, this is very important, microcontroller. And in this lecture we discuss about only 8051 microprocessor architecture only. Okay, there are so many microcontroller available like AVR, PEEK, ARM, but in this lecture we discuss only about the concept of 8051 microcontroller. So first of all, microprocessor meaning the general purpose microprocessors such as the Intel Cross 86 family like 8086, 286, 386, 486, Pentium and Motorola 6800 series. These microprocessors contain no RAM, no ROM and no input-output ports on the chip itself. For this reason, they are commonly referred as general purpose microprocessor. But in a microcontroller, if we see that they contain the CPU, RAM, ROM, IO, input port, timer, serial port, or many other things, ADC like ADC. But in 8051, there is no ADCR available. In a PEEK AVR, there inbuilt ADCR available. Okay, so this is a basic difference between the microprocessor and the microcontroller systems. So first of all, in a general purpose microprocessor system or a general purpose microprocessor system. So first of all, this is a system block. Just to show here, the system block is look like a the system block is look like a, this is a main central processing unit, and here contain the general purpose register control unit and the arithmetic logic unit, and in the external world it is connected through RAM, next ROM, next input output port, next timer, and next serial port also. This is a serial port. Okay, so this is a, this bottom line shows the address bus and top line shows the data bus. So this is the data bus connection from where 8-bit data are coming out, and these address bus where 16-bit or 20-bit address are decoded to selecting the proper address line for memory, or to decode the opcode from this memory. But in a microcontroller the architecture is different, because in a microcontroller in the same block there is a present of CPU, there is a present of RAM. So basically RAM and ROM are just inside in a microcontroller with the IO port, and then timer, then UART, universal asynchronous receiver transmitter facilities, AD converters. These blocks are inbuilt in a microcontroller system. So basically microcontroller is also known as the embedded system, and it is used for the home appliances, telephone, security system, answering machines, fax machine, home appliances, printer, smart TV, cable TV tuner, VCR, lighting control, camera, video games, cellular phones, and in an office there is a microwave, fax machine, security system, laser printer, color printer, paging, and for automation, climate control, entertainment, transmission control, security control, ABS, airbag, engine control, keyless entry. So everywhere microcontroller is present. So that's why microcontroller is very important for today's technology. And this is a advantage of the microcontroller over the microprocessor, because if we connected the microprocessor in a system, then we must develop the system board. That means with a microprocessor there is a connect of RAM, ROM, IO, timer, serial port, etc. There are lots of more complicated design or development, but in a microcontroller the facility is that in a microcontroller all blocks are inbuilt within the microcontroller. So if we just connect the crystal oscillator, that means the clock, then, and if we burn the code, hex code in the microcontroller, then it runs automatically and to process the system as the system requirement. Okay, so this is the very often the term as embedded processor and microcontroller used for these purposes to run the specific applications in today. Okay, so first of all we discuss about the overview of the 8051 family. the 8051 family. Before discussing that 8051, there is a basic concept of the block diagram. So first of all, we discuss about the brief block diagram concept. Here we discuss about the block diagram of an 8051 CPU. Here the main CPU. In this CPU, the general purpose register, arithmetic logic unit, and also, yes, right, control and timing unit are present. And within this CPU, one crystal oscillator is connected. This is external, that is known as crystal oscillator. This may be several frequencies are available, like a 12 megahertz or 11.0592 megahertz. This value of crystal frequency is used for to specific generation of the baud rate of the UART. In the later video, we discuss about that, why we use 11.0592 megahertz CPU. Okay, sorry, clock. Next, here present interrupt control. This is an interrupt. This is an interrupt control, and by this pin, the external interrupt is applied. Now this is here on chip ROM is present, and here the common bus are connected. This is on chip RAM. This on chip ROM or on chip RAM is varying depending on the version of the 8051. In the RAM chip is, and for the ROM chip to decode the code, and these are bus control. Here the bus control, in the bus control logic is coming here, and there are 4 IO ports are used. 4 IO ports are used, which is named as port 0, port 1, port 2, and port 3 respectively, and these bus is connected to this, and here all connected another block known as serial port, and from this serial port 2 pins are coming out, one transmit pin and one receive pin. Okay, and there is another block is connected in 8051 known as timer block. Basically in 8051 there are 2 timers, and also it is used as a counter, both timer and counter, and there are 2 counters are available, timer 0 and timer 1. In the later video when we discuss about the basic concept of timer, then we will be discuss about that. So now first of all, my controller had first of all 121. Basically the 8051, if we follow the 8051, then this is basically 128 bytes of internal RAM facilities are available. That is total 128 bytes RAM's location are available, that is from 00 to 7x hexadecimal memory location. And on chip ROM, basically length, the on chip ROM is 4 kilobyte. So this is basically the length of the on chip ROM facilities. On chip read only memory facilities are available for 8051, and 2 timers, note down, and 1 serial port and 4 ports. All things are embedded in a single chip. So that is the advantage of microcontroller. So it is also referred as a system on a chip. So 8051 is basically a 8-bit processor because the data bus is 8-bit. Okay, that is CPU can work on only 8-bit data at a time, and when data are larger than 8 bits, then it will be broken into 8-bit pieces to be produced by the CPU. Okay, and next one we talk about the thing which is the various parameter of 8051. So please note down for 8051 family. Okay, for 8051, what is the ROM length? What is the ROM length? Yes, right, 4 kilobyte. Please note down in a table form, because this is a very necessary to know for the programming purposes. So what is the RAM location? What is the RAM location? From 00 to 7F, that is total 128 byte memory are available. How many timers are available? 2 timer available, that is timer 2. What is the total number of IO port? 4 IO ports are available. How many numbers of serial port are available? 1 serial port are available. And what are the interrupt sources? There are 6 interrupts are available in a 8051 microprocessor. Okay, so this is the basic parameters which is used as per our design requirement, for embedded design requirement. Okay, either serial port programming, either interrupt port programming, either any sensor data read or write, or any type of embedded system requirement. Then we discuss about this 8051 internal peripheral blocks. So now we look out, the next topic is inside 8051. So our next topic is inside 8051. So what is architecture basically? What is internal architecture? First of all, we discuss about the registers contained in 8051. First of all, basically CPU is register are used for store data temporarily, information temporarily storage, and these 8-bit registers are available, and there are basically the most widely used register in 8051. Please write down the accumulator, then B register, then R0, R1, R2, and up to R7. These are all 8-bit register, and these are programmable register, and one 16-bit registers are available. There is known as data pointer register. These are 16-bit, and another 16-bit register is used, which is known as program counter. So program counter will help us to target the memory, and from the memory we decode the opcode and step-by-step execution, and then our running the applications depending on the programming. Okay, so now this is a general purpose register which is used in 8051, available in 8051 microcontroller. And next we talk about the basic thing. Our next topic is 805 or flag register, or it is also known as PSW. What is the meaning of PSW? Yes, program status word. Okay, in a 8051 microcontroller, basically the flag register are 8-bit, and this is not a user defined because these are status register. Depending on the result, the status is shown in this register. Okay, so there are 8 bits are available. So now this is for parity flag, this is for overflow flag, this is for RS0, RS1. These RS0, RS1 basically for the bank selection. In the later part we discuss about the bank selection. If 0 means available to user general purpose, available to the user for general purpose, this is auxiliary carry, and this is for the carry bit. Okay, so now we discuss about what is RS1 and RS0. This is very important. When this is 00, then there are basically, we'll discuss about thoroughly in the later part. There are basically 4 register bank are available: 0, 1, 2, and 3. When this is 00, 01, 10, 11. And one thing should be remembered: this register bank, partition of this register bank only depend on the RAM location, not a ROM location. This is very important because these are very confusing. This bank separation of bank is basically depend on the RAM locations. So this is for 00 to 07. This location is for 08 to 0F, and this location is for 10 to 17, and this is for 18 to 1F hexadecimal. All are in hexadecimal. Okay. So now this is a bank register of 8051. This is a more important thing. Now we discuss about the register bank in details. So what is a register bank in 8051? First of all, what is the meaning of register bank? This is a bank of register because it's like when we go to the bank and to open an account and to save our money in this bank. So it's look like the same. Register bank is a bank where we store the data permanently or temporarily, and also copy and paste operation available for this bank. But there are some restrictions are available because 8051 microcontroller has total 128 bytes of RAM. First of all, note it down. And there are basically some steps are followed. First of all, a total 32 bytes from 00 to 1F. So first 32 byte 00 to 1F, this location of RAM are assigned for register bank and for the stack. So this is very important. And next, total 16 byte from location 20 to 2F, okay, are set aside for the bit addressable read-write memory. Okay, and number 3 is very important. Total 80 bytes from location 30 to 7F are used for read-write storage, or what is normally called sketchpad memory. So these 80 locations of RAM are widely used for the purpose of storing data and parameters by 8051 programmers, defined by the programmers. Okay, so now we see that all the RAM allocation from 8051, this is very important, this diagram, because depending on this diagram we can write our program. So this is for 00 to 07. This is a register first bank 0. Now starting from 08 07 0F, sorry. This is a register bank 1. Now next, from 10 to 17, this is a register bank 2. Now from 18 to 1F, this is a register bank 3. Okay. Now from 20 to 2F, this is a basically used for bit addressable RAM. Okay. This is a 30 to 7F. This is a basically scratch pad random access memory location. So this is a partition of total 128 bytes of memory. So this is very important to know how the RAM is partitioned in 8051, because otherwise we can't understand the proper way of programming, how data will be shared from this location and how data will be saved in this location. Okay. So there one thing is coming out. There are some topics which should be in our mind. This is very important. First of all, we discuss about default register bank. Student, please note down as I mentioned. So now if RAM location is from 00 to 1F, so see that from 00 to 1F, that means total 4 banks are available. That means 32 bytes, because each bank contained 8 bytes. Yes, right, 8 bytes, 00 to 07. Yeah, right, 1 by 2 byte, like 8 byte. So 4 into 8, total 4 into 8. That means 32 bytes. Okay. So from 00 to 1F, set aside for the 4 register bank, which register bank R0 to R7 to access when 8051 is powered up, and when R0 and which R0 to R7 is accessed when 8051 is powered up. And the answer is that the register bank 0 by default. When the 8051 is powered up, then the RAM location, that means the register bank 0202 07s are available for the first used for the register bank 0. Okay, that is RAM location 0. And 1 2 3 4 5 6 7 are accessed with the names R0, R1, R2, R3, R4, R5, R6, R7 when the programming of 8051. Okay, so now how to switch between the register bank. So the switching between the register bank using the RS1 and RS0 bit, as we mentioned here. So when we RS1 RS0 equal to 00, then this register bank equal to 0, because here one thing should be remembered, this flag register also by the user defined. Okay, but these 2 bit only user defined, and this is also user defined, because other bit are only used for to show the result, what is the status of the result. Okay, this is a parity, overflow, this is a auxiliary carry and carry flag. Okay, so now when this is 01, then we switch to bank 1, then bank 2 and bank 3 respectively. And one thing should be remembered, is very important. And if we look our bank register, so for a bank register, our first bank is from 00, 01, 02, 03, 04, 05, 06 and 07, and the first bank is starting from R0, R1, R2, R3, R4, R5, R6, R7. Okay. Okay, now for the bank 1, this is for the bank 0 allocation, and for bank 1 this is for 8, 9, A, B, C, D, E and F, and this is another location for R0 to R7. So now this is same for bank 2 and bank 3 also. Okay, so this is the process to switch the bank register from one bank to another bank using the register bit RS1 and RS0. Okay, so this is the operation of the bank register in 8051, which is very important. Okay, so some stack operation are performed also in the 8051. Okay, the stack is a section of RAM used by the CPU to store information temporarily, and this information could be data or an address. The CPU needs this storage area since there are only limited number of registers. Okay, and if the stack is a section of RAM, there must be register inside the CPU to point it out. Okay, because we already know that the stack pointer is first targeted by the stack pointer location, and the register used to access the stack is called the stack pointer register. The stack pointer in 8051 is only 8 bit wide, which means that it can take the value 00 to FF. So when 8051 is powered up, the stack pointer register contains the value 07, which means the RAM location 08. Okay, so when power up, the stack pointer register contains 07, which means RAM location 08 is the first location used for the stack by the 8051, because if stack pointer is located 07 when 8051 is powered up, then we already know that this is a stack pointer. So the next location, that means 08, is used for the first location used by the stack for first location used for the stack by 8051. Okay, and there are two instructions are available to store the data in the stack, which is known as push, as you already discussed about another lesson of 8051 microprocessor, and from the retrieve the data from the stack, we use the pop instruction. Okay, so using push and pop. In the later video, we discuss about the thoroughly concept, the elaborately how stack operation are performed in a 8051 register, 8051 microcontroller. Okay, so now next thing is that there are basically 4 ports are available. So now in this lecture, this is our last topic, because in another video we discuss about the another part of the 8051, that means another block. But now next we talk about IO port programming. Our IO port is basically there are 4 ports are available, as we mentioned. So there are first port is named as port 0. So it can be used both as for input and output. And one thing should be remembered, these are very important. Okay, please write down. When P0 pin, port 0 pin is used, then this pin must be connected externally by a 10 kilo pull-up resistance. Why? Because from the concept of circuit theory or concept of digital electronics, we know that for a TTL gate circuit, for these open drain, basically open drain connection, because 8051 is basically a NMOS technology. So if transistor is used, then we called open collector. But as if this is developed by MOSFET technology, so therefore it is called the open drain. So open drain is a term used for the MOS chip. Okay, in the same way that open collector used in TTL chips, as we told that. So now this P0 is pull up by the resistance, otherwise there will be no current flowing to the port. So that's why the port 0 is only the port 0 will be open drain connection. It is your, please noted that only this is open drain connection. So that's why the 10 kilo ohm resistance connected is necessary to transfer the data or to take the data from the port 0. So there are basically 8 ports, are 8 bits of each port. That means port 0 are range from port 0 to 0 to port 0 to 7. So basically 8 bit. And next port 1 is discussed about. This is not open drain. These are basically does not need any pull of resistors, because they are already since they are already has pull up resistor internally. This is internally connection. This is a port A. So port 1. So port 1 basically range from port 1 to port 1.7, and port 2 also this facility port 2.0 to port 2.7, and there are also port 3.0 to port 3.7. So therefore 32 number of pins are basically available for the port programming. Okay, so this is a concept of port programming, port pins. Sorry, in the later video will be discussed about the we just talk about only the hardware part of the 8051 IO port, discussion of the IO ports. Okay, so we also we show the status of the port, and to read the status and write the any code or any data, sorry, not a code, any data to the corresponding port. We use this specific port address to transfer the data for one microcontroller to another microcontroller also. So that's why the port is very important. Okay, so this is the general concept and general architecture concept of 8051. That's all for today. Thank you.